Okay, a very good afternoon to everyone. So it's good to be back in Sri Lanka. So this is my third time in Colombo, so good to be back. Okay, so the next sharing for myself is on the evolution of large language model, and it's from all the way from BERT, GPT-3, and PALM. Okay, so if you're interested, the slide is available here. You can just use your phone to scan the QR code, or just remember the shortened URL bit.ly IO extended -lk -slides. Okay. Next, if you have any questions later, or you can ask during the presentation, you can just go to use a Slido. You can scan the QR code or use the link bit.ly IO extended -lk -Slido. Okay, if you have time, I'll try to answer your question after the presentation. Okay, 5, 4, 3, 2, 1. Okay, so just brief introduction of myself. My name is Kuan Hoong. You can call me KH. I'm from Malaysia. Currently, I'm working as a lead data scientist. I just shifted to a senior manager data science in BAT Malaysia. I'm a Google developer expert, GDE, in machine learning. I'm very passionate about running communities. I founded 2 communities in Malaysia. I founded the TensorFlow Deep Learning Malaysia user group, and also I founded the Malaysia R user group. At the same time, I also run a podcast. So the podcast is called AI ML Data Talk Podcast. So basically, I invite practitioner in the industry. I talk to them, and then I see what do they do, and then what are the criteria when they want to do any hiring. The podcast is available in Spotify. You can actually listen to it for free. Okay, so the agenda of the talk for today is a short sharing section, but hopefully I can actually cover most of the topics that I intend to cover. So I'll just give a brief introduction. What is natural language processing, NLP? What is large language model, and how does it work? Okay, and then what is the evolution of all these language model, all the way from BERT to now what we have PALM and PALM 2. And then I will conclude the sharing. Okay, so I'm sure that everybody is very excited about all these generative AI. Like Eric has mentioned about BART just now. All these large language model, Bing Chat or OpenAI with ChatGPT. So there's a lot of hype of all these model, what this model can do. But basically, all this model is related to what we call natural language processing, NLP. Okay, so natural language processing basically is an algorithm that uses statistical model to analyze, process, and generate natural language, so you can actually interact, okay, between the common human language and the computer language. Okay, so with that, we have evolved into something we call large language model. Okay, so what is a large language model? Okay, so large language model is basically a type of machine learning model. Is trained with massive amount of data set, which is text data set. So when you think about what is text data set, okay, so anything available on the internet, okay, Wikipedia, online, blogs, okay, news, journal, conference paper, okay, e-books, all those texts can be used to train your large language model. Once this large language model been trained, you can actually use it to actually generate more new text or do other tasks. So this is where we call the large language model is also similar to the generative AI. Okay, you can actually use it as part of the generative AI. Okay, let's start from the basic. Okay, so imagine if you were to build a model. Okay, a simple model for your keyboard text prediction. Let's say I key in the letter T. Okay, what will your keyboard predict the next word? Okay, so your keyboard will probably give you 3 predicted word: that, the, or there. How does this keyboard come up with these 3 predictions? How does it know? Okay, of course, the simplest way is, okay, you will say that the most likely word, when you type the letter T, then most likely you want to key in the word the. Okay, how does it know that? Okay, so the simplest way is, okay, if I type the letter Y after T, what will be the most likely word that I want to type? Okay, you have Thai, type, tycoon, typhoon, typanic, or typography. So you have many lists of options. Okay, then what would be the best predicted word that you want to predict? How would you do this? The most simplest way is, I will just look at, the most simplest way is, I'll just look at every single word, okay? I will look at the historical usage. For example, from 1806, the word TYE appear in literature all the way to 2019 has dropped significantly. So the probability of TYE will be used is around 1 in 20 million. It's about 0.000052%. I can repeat the same process for the rest of the word. Okay? Then I will know that of all the word TY, okay, the word type is the highest probability. Then I will say, most likely after I key in the letter T and Y, the type is the next word. Okay? So that's the simplest way, just based on probability, statistical method. Then what I will do, I will rank it in the probability, highest probability. I will just say that after I key in the word TY, the most likely word that you want to type is type. Okay? I can do the rest for the other word. Okay? So, for example, if you have used any search engine like Google, you probably see if I type how, Google will give you suggestion. Most likely you will say, I want to key in how to screenshot of Windows and other suggestion. How does Google knows about this? Based on the usage. Whenever people type how, and what is the other keyword that people type in the search engine. So, from all this data collected, you can actually do a prediction when I type the word how, what I want to search. Okay? So basically, the most simplest language model is just do a probability. Okay? So say, with the probability, I say whether this word, when I type a word, what is the likely of the next word. Okay? Just based on probability. Okay? For example, she just won the 2031 election. Okay? What will be this probability? The probability only occur when the word has been used before. But this word, these sentences here, this sentence here, is a future. There's no probability. Okay? She just won the 2031 election. It hasn't happened. So how do you know the probability? Okay? So that's the problem of this. So, and then in the English word, you have roughly about 100,000 words. Okay? If you were to calculate probability for the 100,000 word, then you run into a big problem. Okay? For example, a typical word will have a typical sentence will have 10 words, and every single word will have a probability of 100,000. And you look at it, your probability calculation will have gone up. Okay? Then you have a 10 to 50 probability calculation that you need to calculate. So now you realize that you run into a problem already. Okay? So let's say I have a lyrics of a song like this. Early one morning, the sun was shining. I was laying in a bed, wondering if she had changed at all, if her hair was still red. And this is a famous Bob Dylan song. So what I can do is, I can use these lyrics now to train on my model. Okay? I can say, I can form a graph for my model. Okay? Every single sentence in the graph, in these lyrics, I will form a graph. Then I will see those repeated words, I will form a path. Okay? I will see here the word was repeated 3 times. So I will form a path like this. Early one morning, the sun was shining, and then I was laying in bed, and then my hair was still red. Okay? Then from there, the same, the word if also repeated 3 times, I'll form a graph. Then what will I do? I'll calculate the probability. Okay? I'll calculate the probability. For example, after the word was, the probability going this and probability going here is 1/3. Okay? After the word if, the probability going up here and the probability here is half, 0.5. Then what I can do, I can form a most simplest model now that I can do by these 2 lyrics. Okay? Then now I can use it to generate text. Okay? For example, I can just transverse the graph. Early one morning, the sun was shining. Okay? Early one morning, I was laying in bed. Okay? So now I can generate text already. Early one morning, the sun was shining, I was laying in bed. Sounds good. Wondering if you have changed at all, if her hair was still red. Sounds good also. But then what will happen? Suddenly I have this path like that. The sun was still red, the hair was shining. Okay, sounds okay. Then I have something like this. The sun was laying in my bed. I was shining, I was still red. Okay, now we run into trouble. The sentence generated doesn't make sense. No logic. Okay, so what's the problem here? Because our model is too simple. Okay, it doesn't make sense. Our model is too simple. So what can we do better? Of course, you can say, oh, instead of just 2 lines of the lyrics, I train it with the whole song. I take the whole song, okay, and then I train it more. Then I generate a sentence like this: she was standing on the side of my mind. Doesn't make sense. How can you stand on the side of my mind? And the shoe was heading out of my face, even worse. And one of my chair was our life together. You cannot live together with your chair. Okay, so even though I've used the whole song, okay, the text generated doesn't make sense. What's the problem here? The problem here is because the word predicted only dependent on the previous word. Too simple our model. We just say the word one is dependent on the word early, and the word morning is dependent on the word one before that. So our model is a bit too simplistic. Okay, so what we can do, okay, so instead of using the one word before that, what we can do now, we can combine 3 words together, more and more words together. We can say the sun here, this the here, okay, or the word morning here is dependent 2 words before it. Okay, it's dependent on the one and early. Okay, so in natural language processing, this is what we call trigram. Okay, if you combine 2 words, it's called bigram. If you combine 3 words, it's called trigram. So you're using 3 words now to form your language model. Okay, so you can say every 3 words, I move my windows, I have all the trigram. Then what will happen? I will say the word predicted is dependent not just 1 word before that, it's also dependent on the next word before that. So the word morning is dependent on early one, the word the is dependent on one morning. Okay, now, okay, let me generate text again. We will meet again someday on the stove. Okay, how can you meet someone on the stove unless you want to cook the someone? Or standing there at the back of shoe tangle. Okay, standing on the stove, even worse. You want to cook yourself? Offer me a pipe. Okay, so what happened? The prediction gets slightly better, but still not great. Okay, so this is the simple evolution of the large language model from a simple probability. Now we simple of co-occurrence metrics. Okay, but how can we do better? Okay, so now we realize, okay, that the word red here is not just dependent on 2 words before it. It's dependent on 3 words before it. It's because it rhymes with the word. It's actually dependent on the 3 words because it's the hair. At the same time, this word red is also dependent on the word bed. Why? Because red rhymes with bed. Okay, so this word red here is dependent on 3 words before and also 10 words before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 words before that. Okay, so you're getting more and more complicated. Not just 1 or 2 words, more and more words dependent before that. Okay, so you can see the word red is dependent now 13 words before that. And you can see now very fast your model getting more and more complicated already. Okay, so then what will happen? If 13 words before that you have 10, again you get back to the same problem. You have about 10 to power of 70 combination of probability. Okay, now our model bursts again. Okay, so how can we do better? Okay, so instead of using probability, now we'll move our model into what we call neural network. We'll try to train it using neural network. So we know the word hair, the word red here is actually dependent on the word red, and the word red here is also dependent on the word bed. Okay, because red rhymes with bed. Okay, so you can say that actually other words here are not important because the word red here is dependent on the word hair, and the word red here is dependent on the word bed. The rest are actually not important actually. Okay, so what you can do, you can try to fit the whole sentences into your neural network and try to see whether you're able to predict the word red or not. Okay, early one morning, the sun was shining, and I will change it all, the hair was still, and you expect the output to be the word red. Okay, so what you can do, you know that if I want to fit into neural network, my data must be in numbers. Okay, data must be in numbers. I cannot just fit in ABCD. So what I can do, every single word that I have in my lyrics now, I can give a number. Okay, the problem is, sometimes certain words, they are closely linked to each other. Okay? For example, the word apex and the word xenix actually having the similar meaning. Okay? Okay, so if they are similar meaning, then you want them to be having similar numbers. No point giving a number, okay, which is very far away. Okay, so what you can do, you can try to plot into this dimension here, where given the word apex and xenix is actually having the same meaning, they should have the same number, roughly closely numbers. Okay, so this is what we call word embedding. Okay, those people who do natural language processing, there are a lot of words that actually have close together. For example, the word ball and sports are closely related, or the word soccer and the word ball should be closely related together because they're having the same relationship. So this is what we call word embedding. There are many people already done all the embedding of the 100,000 English word. It's called word-to-vec library or the GLOVE library out there. So now we evolve. Okay, instead of just thinking of probability, we're thinking about embedding. Okay, now I can just feed in every single word in the relics, and every single word will have a number, and I expect the neural network will be able to predict the word red. Okay, so I can just hide the word red and expect it to be able to predict the word red. Okay, then, as I mentioned just now, actually the rest of the relics is not important because the hair is going to determine the output red, and the word bait actually is determine the word red because it rhymes together. Okay, you know when you write a song, it should be rhymed together. It's the same rhyme. So what we should do, we can fit into our neural network, okay, and the rest of the sentences not important, we should hide it and only give higher priority to those word related or importance. Then you predict the next word, the word that you expect to predict is the word red. Okay? So you can actually train your model now, but sometimes when you train the model will predict the word brown. Okay? Why the word brown is predicted? Okay? The word brown is predicted is wrong because it doesn't rhyme with the word bait. Okay? So what you should do is, instead of, if the model predicted the word brown, you should put more emphasis on those words related to the word red. Okay? So this is what we call attention. Okay? This is what we call attention. Those words that has higher relationship to your predicted word should have higher attention. Okay? So this is where what we call attention model or attention network. Okay? So those words that has higher relationship to the predicted word should have higher attention. Those who have no relationship should have lower attention. So the word had, change, or all has no meaning to the word predicted word should have lower attention, and the word bait here should have higher attention. Okay, so what we do now, we can say that we can build attention model, and this attention model is what we call the transformer model. Okay, so if you heard people say GPT stands for Generative Pre-trained Transformer. So pre-trained transformer is a model that's developed by Google. Okay, so this is what happened. You have the word, let's say I input into my BART. How is it going? It goes to a transformer, it encode and decode the component, and then use the transformer model here. Okay, and then he'll try to output the result for you. Okay, so we have evolved from a simple statistical model to probability model. Now we have evolved to a transformer model. Okay, our transformer model is used just to predict the next word prediction. Okay, so for example, if I type it is, okay, there are many words that is most likely to be predicted after it is. You have the, looking, possible, getting. Okay, and the higher probability will be okay. So you input the word and go through the model again. Now you have it is okay. So what will be the next word predicted after it is okay? You will probably say a lot. Okay. And then after that you feed in the model again. It is a lot. Then after you predict then until to the end. So this is how generally when you ask ChatGPT or BART or Bing Chat to predict, to generate text for you, it goes through this model to predict the next word until it ends with a full stop. Okay, so one of the famous model that is before all this GPT is the BERT. Okay, so BERT model. So BERT model is actually stands for bidirectional encoding transformer model. It's one of the founding, most basic model that people use during the introduction of transformer. So basically the same thing. You can just feed in all this it is blah 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 inside there. Then you have a softmax model. You come in with a prediction. The word with the highest predicted, okay, will be predicted out. Okay, of course, how do you train? You train the model by masking to hide the predicted word. Okay, when the word predicted, then you can compare whether the word predicted is actually the actual word that you want. And then you just go back and retrain the model again. Okay, so we have evolved from transformer model to BERT model. What is next? Okay, so now, okay, if I were to ask chat, okay, for example, but 16 US president was, okay, the 16 US president was Abraham Lincoln. Okay, it cannot be simply give you random answer. Okay, the answer must be only one. Okay, which is Abraham Lincoln. For example, ask you what is the capital of Sri Lanka. There's only one answer. Okay, it cannot predict any other answer. Okay, so how does the model learn all these facts? Okay, so for example, if I ask who's the capital of Philippines, who's the prime minister of Malaysia, who's the queen of UK, the word cannot simply predict. It must predict a fact. Okay, because these are all facts. So how does a model learn all these facts? Okay, so what happened is, it seems like it turned out that you can actually stack more and more layers of this transformer model. Okay, the more layer you stack this transformer model, the higher layer you actually learn more semantic. Okay, you actually learn more logic. Okay, so this is the basis of all this now generative AI, which is your GPT-3. Now we have GPT-4, your Palm 2 model. The more and layer that you stack. As you stack and stack more layers, for example, GPT-3 has 96 layers, Palm has 118 layers. More layers, starting from the lowest layer, it just understands syntax. The higher layer it goes, you understand even more semantics, logic. Okay, that's how the model learns. Okay, so if you look, okay, starting from 2018, okay, and it's just like 5 years ago only, this how fast the this large language model has progressed. Okay, so we have the famous one, which is GPT-3. Okay, so we have GPT-3 here, released by OpenAI, and GPT-3 3.5 was the basis of the ChatGPT. Then Google has released the Palm. Okay, it's about, like I said, 540 billion parameters. At the same time, out there are other models that is also open source. For example, there's a Bloom model, 178 billions, and then there are other models also by other companies. Okay, so this is where we evolve. We evolve from a normal transformer model to a GPT model and Palm model. Okay, so GPT 3.5 is just a improvement of GPT-3. GPT 3.5, what happened is you try to build it more conversational based. Okay, conversational based. So the model that power BART, or the model that power OpenAI ChatGPT, is the GPT 3.5, where now you can actually train it to understand human language. Okay, and then you will generate more human language, kind of natural response similar to human language. So what is next? Okay, so we know that recently, about a few months ago, OpenAI has released GPT-4. So GPT-4 is trained now with more and more data and parameter. It has been fine-tuned. Okay, it's multi-model. Okay, like just what Eric has shown just now, but now not just can generate, can understand text. You also can understand beyond text, image, video, and speech. Okay. So what GPT-4 can do, for example, if it's GPT-3, if you just use the older ChatGPT or BART, it just understands text. Now it can actually train with multi-model. You have audio, video, and text. Okay, one of the fun examples that people have shown that GPT-4, for example, if I ask, what is funny about this image? So you can see, human can understand. Okay, this is an iPhone, and you're plugging a VGA port. Okay, so if you've shown this to a large language model, you expect the large language model to know that this is a weird picture, that iPhone cannot plug in a VGA cable. Okay, so when you ask this question now to GPT-4, he will show you that this is a humor because it's absurd that you plug a VGA outdated connector to a phone. Okay, you understand the context of this. Second thing is you can ask, for example, what is unusual about this image? Okay, so what human will know that this is crazy. The guy is standing on the cap and he's trying to iron his shirt and the back of the cap. Okay, but how does a large language model able to understand this? And so you say that the GPT-4, you said this is unusual, because this guy, he trying to iron his shirt, where he attached a board at the back of a moving taxi. Okay? So, as a conclusion, text is definitely the most important medium communication that we have. As human, the most used communication medium is text. So therefore, the most natural way that we should interact with our machine is using natural language. Okay? And this natural language has definitely progressed significantly in recent years, especially with all these large language model, which definitely has seen that, like what Eric have shown, has a lot of potential, and it's definitely a tool that you will be using in your daily life and also in your work. Okay? So thank you very much. Okay, so if you have any question, I hope that you have asked. I still have like 4 minutes. Can I show my computer? Is there any question? Oh, tons of questions. Cool. Okay, I have like 4 minutes. I try to answer. How do the emerging capability of large language model impact the understanding of, let me, okay, what's the step Google take to prevent AI model collapse? Okay, what do you mean by model collapse? Model not performing, is it? Yeah, so similarly, so one of the problems with all these large language model is that sometimes the large language model actually give you some crazy result. Okay, in large language model term, this is what we call hallucination. Okay, so of course, the model has to constantly evolving and then constantly checking whether the result is correct or wrong. And then as you can see just now, even Bart is still in experimental phase. So when you use all this model, you also, as a user, feedback to the model whether the result generated is correct or wrong. Okay. How does the emerging of large language model impact understanding and management aligning problem, ensure the output align with human value? Yeah, so one of the common problem nowadays is people say that the result generated is wrong. Okay, who is the one supposed to verify or validate the result? Okay, is it the company or is it the user? Or what happens if the result generated cause some risk to the people who use it? So there are a lot of call now to regulate AI. Okay, so definitely for any company out there that when they train the large language model, whether it's Microsoft or whether it's Google or whether it's OpenAI, they try very hard to make sure to clean the data first, make sure there's no biased data, make sure that data is correct, whatever. But of course, sometimes the large language model might still generate some result which is not correct. So it takes some time before all these large language models stabilize. But yeah, it is a lot of effort actually to train all these large language models. So that's why not many companies can actually train their own model. In fact, now a lot of people don't seem to train the language model from scratch. They just go and fine-tune the model. Okay, if you want to use it for your own company, you just fine-tune the model with your own data. Will Bart have an API for deploy? Yes, it's coming soon. How Google Bart differ from popular generative AI? Okay, I think if you just compare the most basic features, ask question and give you answer. Most of these large language model able to do that. Okay, but of course in the future, moving into the future, the how you incorporate all the other, like just now I show you GPT-4, you have multi-model. Okay. And then, like, if it's Bart, if it's Google, because it's from Google, how does it integrate very well with all the other Google product and services out there? Similarly, like now, Microsoft is actually incorporating all these large language model, not just in Bing Chat, and also incorporating all this generative AI into their Microsoft Office products. So you can see sooner or later, the differentiation is how well all these services are well, proper, integrated. Okay, I have one more question. So I try to answer this. Recently, Google changed the privacy policy. Now the policy explicitly grants Google the right to scrap user online posts. Isn't that user privacy violation? Okay, so if you think about it, okay, none of the company allow you to use a tool. Okay, first of all, I'm not from Google, so I just this is my personal opinion. My personal opinion might not represent what Google actually want to do, but I just want to say that there's a lot of services out there allow you to use a service for free. Not necessarily the free service come with you not allowing them to use your data. Just like if you use Instagram, you use Facebook, you use WhatsApp, okay? It's a free service, okay? In return, okay, you also have to give some of data to them, okay? So yes, if you think it's a privacy violation, yes, then you have a choice to not use that service, okay? So I think that's all time I have. If you have more questions, you can connect with me in LinkedIn. Okay, then you can actually ask me more questions there. So thank you very much.
Thank you, Dr. Kuan. Please remain on the stage to receive the token of appreciation. To give away the token of appreciation, I invite Suresh Piris, GDJ Sri Lanka organizer.